So in this objective, we're going to learn how to solve equations that require a root. So to start out, we're going to compare this problem, which is actually very similar, but there are a few differences, and we're going to talk about which one requires a root and which one is solving a radical equation. So in the previous objective, we learned that if we have the square root of the square root of x equal to 3, we can eliminate that square root by squaring it, and if we do this on both sides, then we get our answer. So therefore, I'm going to say that x is equal to 9. Now what this really means is that the square root of 9, if we substitute it back in, the square root of 9 equals 3. And this is true. There's no other number that I could substitute in for this x that's going to give me 3. There's only one answer, so that's why I leave my answer as it was. Now, when we have a slight variation, I have my x squared, some number being multiplied twice gives me 9. This is an equation that requires a root. It doesn't currently have one, but I know that if I want to undo this exponent, I can undo it by taking the square root. And if I do it on one side, I have to do it on the other. Well, this is going to cancel out so that I have x by itself. And the square root of 9 I know is 3, but there's a trick to this. Really, what we're saying is 3 is the only number squared that's going to give me 9. Is this true? No, there is another number. Negative 3 squared will also result in a positive 9. So in these cases, there is more than one number, so when I take a square root, I add this little plus or minus symbol, meaning that my x can be a positive 3 times a positive 3 to give me 9, or my x can be a negative 3 times a negative 3 to give me a 9. So when I have to take a root myself, that's when I need to have a plus or minus. If I already have a root, I don't need a plus or minus. So this is what we call a radical equation, because the radical is already in the equation. Here we do not need plus or minus because there's only one answer. All right? Here, this is what we call an equation that requires a root, and this we do need a plus or minus because there's multiple things that when we square it will give us that positive number. So we need to consider both of those. So if you need to write a little note to yourself, a quick tip: when writing a radical symbol, you must also write a plus or minus. Alright, so this second example is what this objective is focusing on. We've already talked about getting rid of the square root. Now we need to use the square root. And so we're going to see a few examples of problems like that. So looking at number 1, we do have a square root, but we also have this extra term. So for our key point, the first step is going to be use reverse GEMDAS to get our variable isolated. So I am trying to isolate this variable, so I need to remove the 2 by subtracting 2. So I have n squared is equal to 95, and that was using my reverse GEMDAS. Now I still want to isolate my variable, so the second step is to take the root to get rid of the exponent. Alright, so I take the square root, I take the square root, and so I get n by itself equal to step 3, right? Check for plus or minus, right? So this isn't really a check, but make sure you're including the plus or minus. So here, I want to test to see, can I simplify 95? So if I try and divide by 5, I get 19 and 5. So 5 is prime and 19 is also prime. So can I take anything out? No. So I'm just kind of stuck leaving it plus or minus the square root of 95. And that is as simple as my answer can get. Even though it seems like a big number, we can't simplify that. But because I did take this radical, I added this symbol on. I do need to include my plus or minus to let my reader know that this can be a positive square root of 95 or a negative square root of 95 in order to make this equation work. So here again, I want to isolate my variable. I'm going to follow reverse GEMDAS. So I don't have any addition or subtraction, but I do have this negative 9 in front. Since I don't see a sign in between my 9 and my m, I know that this is really a multiplication. So I'm going to divide by negative 9 on both sides, which leaves my m squared by itself. Negative 144 divided by negative 9 gives me 16. I'm going to take my radical to get rid of my exponent. So by taking the square root on one side and the square root on the other, I'm getting just m. And because I drew this in, I do have to write my plus or minus, and 16 is a perfect square. So I know that that has to be a 4, and that is my answer simplified. Looking at 2 more examples, again I want to isolate my variable. So I get rid of this negative 2 by dividing by negative 2 and dividing by negative 2. I have an x squared, and 80 divided by negative 2 is negative 40. If I take the square root and the square root, I now have a square root of a negative number. So if they want me to use only real numbers, this doesn't have a solution because this will give me an error. But if we're allowed to use imaginary numbers, I know that I can factor my 40 to 4 and 10, to 2 and 2, and 10 to 5 and 2. I can take a pair of 2's out, and I also have this negative that I need to take out. So this is going to result in my x being equal to, take out the 2's, my negative means I'm taking out an I, and underneath my radical I still have a 5 and a 2, so a 10. Even though I'm taking out a 2 and taking out an I still need to represent that I took a square root. I drew the symbol in, so I do need to have my plus or minus included. So no matter what, whether it comes out to be a perfect square just like number 2, or if we have a radical answer, or if we can simplify our radical, if it's imaginary, no matter what type of radical you get, if you take the square root, you must include this plus or minus sign in your final answer. And last but not least, we have a few steps going on here. We still want to use our reverse GEMDAS, so I need to get my addition and subtraction away first. So I'm going to add 3 to both sides. So I get 2x squared equal to negative 22 plus 3, which gives me a negative 19. Then I still need to get rid of this 2 in front of my x, so I divide by 2 and divide by 2. Now negative 19 over 2 is going to give me a decimal, and I'm going to leave it as an exact answer. So I have x squared equals negative 19 over 2. So I'm going to take the square root and take the square root. So this is gone, and now I have something a little bit different. My x is going to be equal to the square root of negative 19 over the square root of 2. And this is what we just discussed. I can't have a negative number I can't have a radical in my denominator. But I do have to remember that I took a square root. So already I have a plus and a minus in front of this work. but I also have to keep going and take care of this radical in the bottom. So I'm going to multiply by the square root of 2 and multiply by the square root of 2, which is going to give me x is equal to plus or minus. I'm going to multiply on the top. So negative 19 times negative 2 is going to be the square root of negative 38. And square root of 2 times square root of 2 is going to give me just a 2. I want to check if I can simplify my negative 38. And I have a 19 and a 2, both of which are primes. So I cannot take out any common pairs. So all I can do is take out this negative. So I'm going to have x is equal to plus or minus I. The 38 is going to stay inside. The 2 stays below. And that is as much as I can simplify. So there might be a case where even once we take the square root, we end up having this radical in the denominator, and we need to rationalize our radical. So even though we are solving an equation, all of the things we've learned about radicals still apply. The common mistake I would say here is that we forget this plus or minus, because even though we take the square root, we're doing other things with it, like rationalizing, so it's really easy to forget your plus or minus. So please remember, anytime you take the radical, the very first thing you should write next is your plus or minus, and just remember to carry that down all the way into your final answer. So that's it for this objective. Here we have 3 problems for the self-check. So just make sure that you are following the key points, and do not forget your plus and minus symbols. Good luck, and we'll see you back in class with questions.